we filming? Okay, we're going to do a density video. We're going to do a density lab using a graduated cylinder, some water, a triple beam balance, and 4 pieces of crayon. All right, now she's videoing this, but you're also going to do it today. It's set up around the room. So what you want to do is we're going to find the densities of one piece of crayon, and the density of 2 pieces of crayon, and 3, and then 4. Now, in your head, you don't have to blurt it out right now, but I want you to think, will the masses be the same as I add them in? Will the volumes be the same, or will the density be the same? What's going to happen? So what we're going to do is the standard operating procedure is to do this. Make sure this little knucklehead right here is balanced down to 0, and it is. All right, then we're going to put 1 piece of crayon on there, and we're going to find the mass. All right, and to find the mass, we use the triple beam balance, and we slide that over until we get to something, which that one looks like it's about 2.25. All right, so the mass of 1 crayon is 2.25 grams. Now, what I want to do then is I want to take that piece of crayon and I'm going to find the volume of that crayon. And that's the way I'm going to do that is I'm going to do water displacement, and I'm going to pour some water in this thing. Now, it doesn't matter how much water we pour in it so much as long as we can read how much is in it. And right here I've got to get down a level, and this little rascal says 23 milliliters, and then when I drop the crayon in it, what's going to happen to the water level? It's going to rise, and now it is at 24. All right, so what is the volume of that 1 piece of crayon? 1. So the volume then of let's do a volume section. The volume of 1 is 1 milliliter. All right, and we're going to record that on this piece of paper. So we're going to do 1, and then I'm going to need to take this crayon back out, because now I need to find the mass of 2 crayons, and then find the volume of 2, and then the mass of 3, and then the volume of 3, and then the mass of 4, and the volume of 4. Yes?
Would it add to the mass? With it being wet, is it going to make it way more than that?
Probably so. Great question. Great question. Might want to get them all wet first, so that it'll always be wet. How about that? That's not a bad idea. Find the volumes first. It doesn't matter to me how you do it, but you need to understand that you need the volumes of the same 1 and 2 and 3 and 4 as you're comparing the masses to, so that you can find the densities. Am I making sense? Amen?
Amen.
No, amen?
Amen.
All right, so then what you're going to do is record this on here, and then we're going to graph it on the back of this thing. Okay? Now, the one thing you want to make sure you have is the same color crayons, and you need to remember this. Does anybody remember what the density of water is? You don't remember what the density of water is? If something is more than this, it sinks. Less than this, it floats. The density of water is 1 gram per milliliter. So, if these sank, what should their densities at least be?
More
than
1 gram.
1. If they float, they should be. All right, so as you do your experiment, you need to kind of pay attention to that. Yes? And you need to make sure you have the same color and type of crayon. Because if you start dropping in different ones, they may be, different crayons may have different properties. Yes? Amen? All right, you're awesome. You can stop the video now.